Hello friends, today I am going to teach about the photochemistry. Myself, Louis, chemistry assistant professor from Government Sejip College, Mizoram. And in this topic, it will include introduction, laws of photochemistry, Frank-Condon principle, Jablonski diagram, photosensitization, quantum yield. Introduction. Photochemistry is the branch of chemistry which deals with the rate and mechanism of reaction taking place due to exposure of light. The reactions which can be brought by light radiation are called photochemical reactions. The term radiation includes radio waves, X-ray, gamma ray, and beams of particles like alpha particles, electrons, neutrons, and protons. And you see the visible light region is the wavelength of 400 nanometer to 700 nanometer. The study of photochemistry helps us to know the changes when a molecule absorbs radiation. Terms commonly used in the photochemistry. Excited states is one of the very common terms. Excited state means that the electrons which is in the ground state is going to the excited state. Excited state, that means it absorbs energy. When after absorption of the energy, it is returned to the ground state in a different way. That's what the photochemistry is very important. Here in this case, directly the ground state to the excited state, that is S1. S1 is the singlet excited state. Singlet excited state is the spin multiplicity is 1. But rather than that, sometimes the singlet excited state is going to the triplet excited state, which is spin multiplicity is 3 and which is more stable than the singlet excited state. And most of the cases, electron is excited to the singlet excited state because which is the same states of the ground electronic state. And laws of photochemistry. Grotthus-Draper Law. Only those radiations which are absorbed by a reacting substance or systems are responsible for producing chemical change. That means that not all the radiations cannot produce reaction. According to this law, all light radiations are not bringing the chemical reactions. Some are increased kinetic energy of molecule while some are re-emitted. Lambert Law. When a monochromatic radiation is passed through a homogeneous absorbing medium, the rate of decrease in the intensity of radiation with thickness of absorbing medium is directly proportional to the intensity of the incident radiation. Di divided by dx is proportional to I. And the next one is Beer-Lambert Law. When a monochromatic radiation is passed through a solution of absorbing medium, the rate of decrease in the intensity of radiation with thickness of absorbing medium is directly proportional to the intensity of the incident radiation and concentration of the solution. Here you see this is the medium. Here I0 is the incoming intensity. I is the intensity after passing through the medium. And we have di divided by dl proportional to Ci. As you see, A is equivalent to epsilon C and L. This is the Beer-Lambert law. In Stokes-Einstein law, this is also one of the very important law. Each molecule of absorbing substance absorbs one photon or quantum of the radiation in primary process. A molecule acquires energy by absorbing photon as A plus h nu. A is the substance which absorbs h nu amount of radiation. This h nu is one quantum of photon. It produces a star, which is excited molecule. Energy of photon is E equal to h nu. This one is very important. E equal to h nu, and this is the Stokes-Einstein's law of photochemistry. One quanta of photon is always having h nu. As you see that h nu is a packet of energy. If the value of h nu is less than the value of the molecule for activating to the reaction, this H nu will not create the reaction. That means the reaction will not be proceeded. If H nu is more than enough or enough for the reaction to reactant to be activated, then the reaction will be proceeded to the product, towards the product. And the other one is Franck-Condon principle. Here, Franck-Condon principle is the excitation of electrons. As you see, the ground state electrons here, nu 0, 1, 2, 3, 4, and so on. And this one is nu prime 1, 2, prime 0, prime 1, prime 2, prime 3, something like that. This is the excited state, and the other one is the ground state. When the substance or the molecule absorb energy from light, that is radiation, the electron from the ground state is promoted to the excited state, and this excited state contains a higher energy. From this, the molecule cannot always be stayed in the excited state. It releases energy and to be stay back to the ground state. And this release of energy in the form of light, if it is in the form of light, we have some emission of light. If it is in the form of heat, we have some form of heat in the chemical reaction, that is exothermic reaction, like that. Franck-Condon principle, it describes the intensity of vibronic transitions or the absorption or emission of a photon. This one is the basic principle of UV visible spectroscopy. And then we'll go to Jablonski diagram. It is a pictorial representation of the absorption and dissipation of energy by the molecule. Here you see excited singlet state and is the ground state. The ground state from the excited singlet state, that is S1, and some molecule or some electron will jump to S2 level. In the excited state level, from S2 to S1, it is internal conversion or vibrational relaxation in the vibrational spectroscopy. And after that, from S1 to directly it is going to the ground state by the release of light. We call it as fluorescence. That means the light is produced during this, some substance or some molecules, when it exposed to the light, it produces another kind of light, another different kind of light. Those are known as fluorescence. And the other one is from S1 level to triplet state T1, that is excited triplet state. Here in this case, the transformation is non-radiative relaxation or delay fluorescence or intersystem crossing, whatever it is. And from this T1 to ground state, sometimes it is non-radiative relaxation, and sometimes it is, here you see, this one is phosphorescence, like some compounds which, when exposed to the light, after cutting off the light, it will still produce the light. That is, they are known as phosphorescence. This is the Jablonski diagram. This is very clear and very easy to understand. And let us go for the fluorescence. In this fluorescence, atom or molecule return from excited state to ground state with emission of radiation is called fluorescence, emission of light. Like in this case, emission of radiation, light is produced. This light is most probably it is different from the incoming light. That means the light which is absorbed. And then the electronic transition of electron is depending on wavelength of radiation in case of some atoms. Wavelength of fluorescence in some as absorbed radiation is called resonance fluorescence. When a photochemically excited atom collides with another atom, intensify the fluorescence radiation is decreased, is called quenching of fluorescence. And next is phosphorescence. Even after incident light radiation is cut off, there is emission of light for some time is called phosphorescence. It is also called slow fluorescence. Sometimes they used to call it slow fluorescence, but popularly known as phosphorescence. The substance which shows phosphorescence is also known as phosphorescence substances. This is the substance in light with white light, and this one is UV light, and another one is total darkness. Even in the total darkness also, the substance is giving light. It is clearly seen, visible. And chemiluminescence. The emission of light as a result of chemical reactions at ordinary temperature is called chemiluminescence. Some chemical reactions, when it is taking place at normal temperature, ordinary temperature, or room temperature, it produces a light that is known as chemiluminescence. It is the reverse of photochemical reaction because light is given out instead of being absorbed. In chemiluminescence, excited product emits radiation of the appropriate wavelength, which is lying in visible region of the spectrum. One of the very common example is firefly. As you see that when you see firefly, it produces light. Then this light is due to the chemical reaction photosensitization. The process of initiating a chemical reaction using a substance capable of absorbing light and transferring the energy to the desired molecule. As we see that the photosensitizer, that is the chemical substance only, that alone cannot produce the chemical reaction, and even the light alone cannot produce the chemical reaction. When the photosensitizer and light combine together to form changes in organism. Changes in organism means that chemical reaction is taking place. Then here the excited molecules present in the S1 to T1 state can transfer its energy to another molecule, which is then undergoes chemical reaction, and the first molecule come to ground state is called photosensitization. The first molecule is known as photosensitizer. This one photosensitizer, which absorb energy to himself, and then he can pass that energy to some other substances, and that some other substances produce chemical reaction that the photosensitizer itself can going down to the ground state. This is the principle of photosensitization. And then quantum yield. Quantum yield is a measure of the efficiency of photon emission as defined by the ratio of the number of photons emitted to the number of photons absorbed. Here in this case, it is photons emitted divided by photons absorbed. The substance which emit the photon and the substance which absorb the photon, that is the quantum yield. In the high quantum yield, the product of primary process activate the second molecule to third molecule, and so on. That means the chain reaction was occur, and in this case the molecular reaction is very, very fast. And another important point is the intermediate between the reactant and the product. The intermediate formed as a catalyst. That means it can activate another second molecule, and then that produce the product, and on the way to the product it activates another intermediate which can act as a catalyst. Just here in this case the reaction will be fast. And another one point is exothermic reaction activate more molecule. And why some compound has a low quantum yield? The activation of activated molecule takes place. Activated molecule without causing to the reaction, it can be deactivated. And then sometimes after the product was formed, then the product itself can react together to form back the reactants. That means a reverse reaction is also taking place. Thank you so much. Thank you.